Okay, Unit 1 test review. 16 problems on it. I'm going to go over like a sample. You're going to do a review on your own in this video here. Okay. Unit 1 assessment review. Okay. Alright, so you are going to, when you're solving equations, you want to make your boxes. You're solving for the variable. Okay, so you have 4y minus 6 equals 2y plus 8. Your job is to solve for y. Okay, if you're just solving with equal signs, you're not going to need a number line, so you can do one problem per box. Will probably be okay. Okay, just pointing that out there. Okay, so we have two y variables in this problem. We obviously have to get it down to 1. So they're on opposite sides of the equals, so I mark the smaller one, get that 2y to a 0 by subtracting 2y. Line up your equals. 4 is 2y minus 6, and then you have 8 on that side. So now you're down to 1y. Okay, it's over here. So 2 times y minus 6. Okay, so 2 is the multiplier. We got to get rid of the minus 6, so you add 6. 2 times y equals 14. Then you divide by 2. And 14 divided by 2 is 7. Okay. Next one, 3 times the quantity x plus 1 equals 35. Solving for x. Okay, you need to apply the distributive property first, okay, because you got the 2 with the x, the 1 without. So 3 times 2x is 6x, and 3 times 1 is 3. Nothing else over there equals 35, and now I can solve the equation pretty easily. Okay, multiplier is a 6, so we got plus 3, so minus 3 minus 3. It's going to give us 32. Divide by 6. 32 divided by 6. You can round that to 5.3. Since I don't know how to type repeating bars on the document. Okay, and we move along. 5 times the quantity 3w minus 2 minus 7 equals 23. Solving for w. So again, you apply the distributive property. So 5 times 3w is 15w. 5 times 2 is 10. And you still have the minus 7. Okay, so I have w with a coefficient multiplier of 15. Now these two we might want to add together. Okay, put those combined like terms there. It'd be a negative 10. It's like a negative 10 plus a negative 7. That would make negative 17 or minus 17, however you want to put it. Okay. At any rate, you would have to get that to a 0 by adding it. 23 plus 17 is 40. So 15 times w equals 40. Okay, 40 divided by 15, you get some kind of weird answers when doing these. 2.6 repeating, that would also be 2 2/3. But I'm fine with decimals for solutions. Okay. Next one, x minus 2, parentheses 3 minus 2x equals 2x plus 9. Okay. So a lot of x's in this problem. Well, the first thing I want to make sure of is that every x I know the coefficient. Got a 1x, a 2x, 2x. Okay, so I need to just apply the distributive property. So over here I know I have 2x plus 9. Now the multiplier is a negative 2. Remember, if it's minus, it's like a negative there. You would times it by 3. And then you would times it by negative 2x. Remember, know the signs on what you're timesing. Having a minus in front means it is multiplied as a negative. You can put the plus negative if you want. Negative 2 times 3 is negative 6. Negative 2 times negative 2 is 4x. I would put the 4x first. That's just me. You can either write minus 6 or plus negative 6. It means the same thing. and then add the 1x into the equation. Okay, so the distributive property has been done, but I have 3 x's in the equation. Okay, well, the first thing I'm going to do is add these two on the same side. 4 plus 1 is 5. 5x plus negative 6 equals 2x plus 9. Now I have x's on opposite sides. I eliminate the smaller one through subtraction. Gives me 3x plus negative 6 equals 9. And you add 6. 3x equals 15, divide by 3, and 15 divided by 3 is 5. Okay, a lot of work on that one, but I got through it. I applied the distributive property. Again, when you have multiple x terms in the problem, if they're on the same side, you just combine them by adding. Opposite sides, I would like to get the smaller one to 0 by either adding or subtracting. Okay, next one, we got 5 times the quantity x minus 12 minus 24 equals 3 times the quantity x plus 2. Distributive property there. If you want to put a 1, you can. 5 times 1x is 5x. 5 times 12 is 60. You can put plus negative 60 if you want. And then we have the minus 24. Distributive property over here, 3x plus 6. Now the question is, again, we have multiple x terms in the problem on opposite sides, so I subtract 3x. That takes us to 2x minus 60 minus 24 equals 6. Okay, so I'm down to just 1x with a coefficient of 2. Okay, so over here, I would want to combine those now. Okay. Remember, know what you're combining. You're combining a negative 60 and a negative 24. You're adding them together. Negative 60 plus negative 24 is negative 84. And then we would get the negative 84 to a 0 by adding. Okay, I'm going to use this square here because it's kind of... Okay, 2 dot x. 6 plus 84 is 90. Then I divide by 2. And I end up with 45. Okay, so apply the distributive property, then simplify the equation so the x term appears only once, and then go from there. Okay, 2x plus 7 minus x equals 3 plus x plus 4. Multiple x's within the same equation. So this x has a coefficient of 2, this x here has a 1, and then the x on the other side has a 1. So I would want to combine the two on the same side by adding, okay? Remember to know what you're adding. You are adding a 2 and a negative 1, okay? 2 plus negative 1 is 1, plus the 7 equals, and over here I just got the 1x right here, okay? 3 plus 1x plus 4, okay? Now I have x's on opposite sides, but there is not a smaller one. We get rid of the x's then, and this becomes either an all solution or a no solution. So on one side we have 7, on the other side 3 plus 4 is 7. So 7 is equal to 7, that's all solutions. That means any number I plug in for x makes this expression equal to that expression. Okay, 5a minus 1 sorry, my bad. 5a minus 1 minus 3a equals 2a plus 1. Okay, again, you have multiple variable terms. You're solving for the a. First, we need to simplify this so the a term appears only once. That's what we have to do first. So the a is on the same side. We add those. 5 and negative 3 makes 2a minus the 1, or plus negative 1, equals 2a plus 1. And then we end up in the same situation when we have a's on opposite sides, but they're the same, so I can't really pick a smaller one to get rid of. So does negative 1 equal positive 1? No, that's a no solution. Okay, that means there doesn't exist a number you can put in for the a and have the equation equal out. Okay, number 8. When you get into these problems, 8 through 13, I would suggest you're using 2 boxes per problem. Okay, that is how I would do it. Or actually, why don't you just use as much room as you need, okay? We have the equation 4 minus x equals the absolute value of 2 minus 3x. Whenever I'm solving an equation with an absolute value, I'm going to want to make a table, okay? So in the absolute value, you have 2 minus 3x. Okay, your absolute values on this side. Do you have anything outside of it? Do you have any plus or minus after it or any time? No, you don't. So you can go ahead and put 4 minus x. But when you go on the other side, you got to then flip it to negative 4 plus x. Okay, now you're solving 2 equations. Okay, so I've got these x's, the negative 3, negative 1. Well, negative 3, they're on opposite sides, so I'd want to add 3x to the negative 1x. So I have 2, and then negative 1 plus 3 is 2x plus our 4. Okay, now it's simplified, so I have the x with the coefficient 2. We got to do the opposite of plus 4, which is minus 4. 2 minus 4 is negative 2, and then 2 dot x. Then divide by 2, and x equals negative 1. Okay. So I have a negative 3 and a positive 1 over here. I'd want to go after the negative 3. So plus 3x. The reason I always go after the smaller one when they're on opposite sides is so that my x multiplier doesn't end up as a negative. But really, if you did it the other way, it'd be fine too. Okay, so 1x plus 3x is 4x, and then plus the negative 4 or minus 4. So I have a coefficient of 4. We have to get the negative 4 to 0 by adding 4. I hate writing against this spiral. Okay, 2 plus 4 is 6 equals 4 dot x. Then I can divide by 4, and 6 divided by 4 is 1.5. Now what else are you supposed to do in that problem other than solve it? You need to do the extraneous solution check. So you go on the side where the absolute value is not there, okay? Not in the absolute value. We can't have a negative number over here because an absolute value can't equal a negative. So if I go 4 and subtract negative 1, that's a positive, so that one's good. Now if I take 4 minus and then substitute 1.5, that's not a negative either, so therefore both of those solutions are valid. Okay. Alright, next you're solving inequalities, so we need number lines. Okay. 3x plus 17 greater than or equal to 5. Okay. Okay, so the first thing I need to do is solve the actual inequality. Then I'll bring my number line. We know the inequality ends up in a number line. That's a dead giveaway. Okay, so only one inequality, so I just solve it. We have a coefficient of 3. Now the coefficient's positive, so that sign will stay the same. Like that, it will not switch. Then minus 17, minus 17. 5 minus 17 is negative 12. Then we divide by 3, and that gives me negative 4. And now I can come over here because I know what I'm graphing, what direction. So negative 4 is our critical number, circle. When this inequality opens up towards the x, it is going to go in this direction. Okay, and that's the answer. Okay, next one we have 25 minus 2x greater than 11. Okay, so here's the x. Our coefficient is a negative, so that means our sign will flip because I'm going to have to divide by the negative 2, but first I have to get rid of the 25. Okay, so I'm minus 25. So line that up. 11 minus 25 is negative 14. Now when I divide by our coefficient, that's when the sign changes. So we have x, negative 14 divided by negative 2 is 7. So I have 7, circle. This time it opens towards the 7, so it's any number less than 7. So that's any solution right there. Okay. Alright, moving along. Okay, now when you look at problem number 11, you see it's a double inequality. It says 3x less than negative 6, and then the phrase or 5x greater than 20. So I'm going to want to make a table to solve them separately. And we still need the number line, just right there. Alright, so 3x less than negative 6, that shouldn't be hard, neither should the other side. Getting it on the number line and labeled, that can be. So here's the side where the x has a coefficient of 3 positive, and there's no other operation other than to divide by 3. So divide by 3, divide by 3. So x is now by itself. Negative 6 divided by 3 is negative 2. Then over here on the other side, what do we have going on? Well, we got a multiplier of 5. Since that coefficient's positive, we know that that symbol will remain greater than. There's nothing to add or subtract, so now I apply the division property of equality by 5. And now the x has no more operations around it. 20 divided by 5 is 4. So negative 2 and 4 are the critical numbers. Opens towards a 2, so that goes this way. Opens towards the x, so when it opens towards our variable we're solving for, that means a variable goes this way. And those are separate. We keep them, the labels separate, then we don't combine it into one. It's not a compound. Okay, next one. 2 less than 4d plus 10 less than 6. I know that looks different than the last one, but the procedure is exactly the same. You just have that as an inequality on one side, and then overlap the circles, and then you have 4d plus 10 less than 6 on the other side. Okay? And we will need to bring in the number line then. Whenever you're working with inequalities, we represent with a number line. Okay, variables over here, multiplier of 4 and a plus 10. So we know the multiplier of 4 means the sign stays that way. So I minus 10 from the 2, and that takes us to negative 8, 4.d. Remember, when you're adding and subtracting, the symbol is just lined up. Then we divide by 4. Now remember, since the d appears over here, you need to put it over there. Negative 8 divided by 4 is negative 2. Okay. Over here, 4 times d, and then minus your 10 from the 6. And we know the symbol wouldn't change because the multiplier is a positive. 6 minus 10 is negative 4, then divide by 4. And we have d, negative 1. So negative 2 and negative 1 are your critical numbers. Don't fill in either one of them. Here it opens towards a d, so it's going that way. Here it opens towards a negative 1, so we go back the other way, and that's combined. Okay, it can be any number in between there, so it could be negative 1.5, so that's why that's connected. So we have our variable, negative 2 on one side, negative 1 on the other. Open it towards the d between the negative 2, open it towards the negative 1, that way. Okay, then number 13 is kind of hard to remember what to do. You got 5, and then you got the absolute value of 3w plus 2, and then after that minus 3, and then greater than 7. Alright, so we know when we're working with absolute value, we want to make a table. Okay, now you can make it here. I would put it down here, okay, because you got some work to do before you finish going to your table. You know you're going to have the expression 3w plus 2. Now I'm going to kind of separate that side, but I have operations outside of our absolute value. We have a subtraction of 3 and a times 5. You don't apply the distributive property into an absolute value, okay? It's not like a parentheses. You need to first add the 3. That would take us to 10. And then we need to divide by the 5. Now since the multiplier 5 is positive, the symbol will not change. If that was a negative 5, I would be flipping the symbol before I went to my table. But the multiplier is a positive, so when we divide by 5, that's 2. Okay? And I know 2 is the number I'm going to use on my table. Then we can go 2, negative 2. So keep the symbol the same, and then flip it. Okay, so you have a multiplier of positive 3, so the symbol wouldn't change. Minus 2, that's 0. Divide by 3. Now 0 divided by 3 is 0. 0 can actually be a critical number. Okay, that's okay. Over here you repeat the same process. Minus 2, 3 times w, negative 4. Then divide by the 3. Negative 1.3 repeating, so those are your critical numbers. 0 I guess you have, and then negative 1.3, or negative 1 1/3, or negative 4/3, it's all the same, okay? Neither of them are equal. You eat the w on the 0, so greater than negative 1.3 that way, okay? So they're separate, keep them separate then. Just label them separately. Okay, that'll be one that's hard to remember how to do when you have both an absolute value along with an inequality. Okay. So here's just solving for the variable. Number 8, absolute value, check for the extraneous solution. Solve the inequality graph, your solution. The 9 and 10 are easy, you just got to watch out for the sign flipping. Then when you get to the double inequalities, make the table. You know you're looking for two numbers. The arrows either go together or come apart. Number 13, absolute value. You're going to use your table, then you need to clear the outside operations. Add 3, divide by 5. And if that 5 is a negative, which I'm probably not going to be that big of a jerk on the test, but watch for the sign flipping before you get to the table. Now we're to story problems. These aren't too terribly hard, okay? Remember when I'm doing story problems, I like to separate the paper in half. The fare for a taxi is $5 per trip plus 50 cents per mile. Dollars and miles are the two key units. It says per trip, but it's just one whole trip. The fare for the trip from the airport to the convention center was $11.50. How many miles did the taxi cab drive? So we're figuring out miles. I'm going to put that right there. And again, I'm going to do a unit analysis. That's kind of what you do in algebra. And dollars and miles. Remember, X and Y, time is X, but there isn't a time, but we know money can't be X, it's always Y, and then miles is X. So per, dollars per mile, we have that's 50 cents. So I connect an X to it because it's 50 times the number of miles, which is represented by X. Then I like to make a table. Do you have to? No, it will help later on, but not going to get in fights, okay? X, Y. I mean, I'm not scared of a fight, but that's not worth fighting over, okay? Miles, dollars, okay? So since I know my dollars per mile, I'm going to label this 0, 1, 2. Now, at 0 miles, you had to pay the $5, okay? Then you add the 50 cents, so $5.50, 6, and that continues on, okay? Then I make my line. It's like a graph. You start off at 5 plus your slope of 50 cents equals y. Okay. So you have your equation. You got $5 plus 0.50x equals y. Now, we know we paid $11.50. We're trying to find out how many miles that was for. So we put $11.50 in for y. And now I solve for x. It has a coefficient of 0.50. First we have to take the outside 5 to a 0 by subtraction property of equality. So 1150 minus 5 is 6.5, and then 0.50 times x. Then we can apply the division property of equality. And that's 13. Okay, so x is 13. Okay, number 15. Tracy's looking at 2 travel agencies to plan her vacation. ABC Travel offers a plane ticket for $295 and a rental car for $39 per day. M&N Travel offers a plane ticket for $350 and a rental car for $33 per day. Approximate how many days it will take before M&N Travel is actually the better deal. So you're figuring the number of days. And the unit analysis means we have dollars and days. The time is x, dollars is y. So per, dollars per day. Okay, dollars per day, we actually have 2 of them. We have 39 and 33. They're separate, okay? So we would have 2 separate tables here, okay? So xy, xy. Days, dollars, days, dollars. Since we know the 2 rates of change, it would be 0, 1, 2, 0, 1, 2. Okay, now before the $39 per day, the guy who's doing the 39, he starts at $295, and then his cost goes up by 2 by 39. So $295 plus 39 is $334. Remember, I'm adding 39 plus 39 is $373. And this guy here, before the $33 per day guy, he starts at $350, then start adding 33, $383, $416. Okay. Alright, we want to know when those are equal, so that means we're going to make 2 lines. Okay, and he started at 295, he started at 350. This guy is increasing by a slope of 39, 39x equals y. This guy is increasing by a slope of 33. Now, ditch your y's, you don't care about those, you want to know when those are equal. How many days are equal. So you want to know when 295 plus 39x is equal to 350 plus 33x. Okay, 2x variables, so we pick the smaller one. Get that to 0 by subtracting. So that's 6x plus the constant 295 equals 350. Okay. So we have a times 6. I like to circle the times or divide. Okay, that's just me, because I know what I have to get rid of then. Minus 295. That's 55. So 6 times x equals 55. So 55 divided by 6. Okay, now they want after how many days it's the better deal. Well, so 9 wouldn't be the better deal yet. You'd have to get up to 10 days for that to be the better deal. Okay, I know that doesn't round to 10, but if you think about it in the context, you want to go up to 10. Okay, the last problem short, if you can remember kind of the process we're doing. It's a complex ratio fraction problem. There's 1 freshman in a cast of a high school musical. There are 6 sophomores and 11 juniors. 1/3 of the cast are seniors. How many seniors are there in the musical? Now, they're talking about a ratio fraction problem. So we know we have the rate and the actual. Okay? Rate actual. Okay, the rate, 1/3 are seniors, okay? So that's your total, that's seniors. Now you go up above it, and that would leave us with 2, because 3 minus 1 is 2, that are not seniors. Then you line them up, okay? Well, we know how many are not seniors, okay? I mean, freshmen, sophomores, and juniors, by de facto, those are not seniors. So 1, 6, and 11. So 1 plus 6 plus 11, it's 18. So 2 times what's 18? Well, 18 would be 9, okay? 1 time, so there'd be 9 seniors and 27 total. So they want the number of seniors, which are 9, okay?